Hey, what's up guys? This video is for section 9.1, which is graphing quadratic functions in standard form. So first of all, let's understand what's the standard form of a quadratic function and why we call it a quadratic function. So you guys see the function here, f of x equals ax squared plus bx plus c. You guys have a, b, and c, which are numbers. There will be some negative numbers and positive numbers. So that is the standard form of a quadratic function. Why is it a quadratic? Because the highest exponent is 2. You have an x squared. If you have a function and there is no x squared, you don't see an x with a squared, then it's not a quadratic function, it's a different function. But this one will have an x squared. So before we start actually graphing in standard form, I want to show you guys the most simple, easiest graph that we can do in a quadratic function, which is the parent function. So you guys see that one here, f of x equals x squared. And I'm going to use a table in order to graph the function. So for my t table, I have some x values, which are my inputs. And I'm going to input those numbers into the function. I'm going to substitute. And I'm going to find my outputs, which are the y values. That's what we do when we have a t-table. You guys plug in the x values, you substitute, and you guys get out a y value. And once we get those y values, I'm going to graph the points, and then we're going to connect the points, and you guys will see where the shapes come from. So the first one is -3. So I'm going to take this number, -3, and I'm going to substitute into the x with the square. So f of x equals x squared. Something else that you also have to remember is that f of x is also a y. So you guys can say f of x equals x squared as y equals x squared. So the y and the f of x are the same thing. So once we are looking for y, we are looking for the f of x at the same time. So they're the same thing. So let's go ahead and substitute the -3. So I have a -3 squared. And that's going to be positive 9. And I substitute a -2 squared, that's going to be positive 4. And then the -1 squared, that's going to be 1. And the 0 squared, that's going to be 0. You do 1 squared, positive 1 squared, that's going to be 1. And then we have the 2 squared is 4. And the 3 squared is going to be 9. Remember that I'm taking the numbers -2 and I substitute into the x squared. I take the -1, I substitute into the x squared, and then the 0, the 1, the 2, and the 3. So those are my my tables or my table. Now I'm going to take my point -3, 9. I'm going to graph it. It's going to be 1 point, and then I graph -2, 4, and then I graph -1, positive 1. So let's go ahead and graph those points. So you guys see the points on the graph already. I graph all those points there. Now I'm going to connect the actual points. So when I connect the points, you will see the shape. Look at the shape. Is becoming a U shape when I connect. So we say that the quadratic function is a U shape. Now there's an actual name for that U shape, and it is parabola. The parabola is a quadratic function where the graph is a U shape. But I want you guys to notice a couple things that you can use later on to make the graphing part a little bit easier. So first, I want you guys to see the y values on the table. We have a 9, 4, 1, 0, 1, 4, 9. So you notice that the numbers are repeating from the top of the 0 and the bottom of the 0. If you guys take the 0 as a point of reference or reference point, after the 0 we have a 1, 1. And then we have a 4, 4, and then we have a 9 and a 9. That's a pattern. In a parabola, in a U-shaped quadratic function, you guys will have a pattern repeating again and again on the left side of the 0 and the right side of the 0. How does it connect with the actual graph? Well, when I look at the 0, 0, this is the origin, and imagine that I cut the parabola in half. And let me do this right now. I'm going to make a dash graph or a dash line on top of the y-axis. And you notice that that line is cutting the parabola in half right here. So the left side of the parabola on the left side of the line, the dash line, is the same thing as the right side. So notice this left side is the same thing as the right side. If you guys are able to fold that parabola through the dashed line, this is going to be on top of this part of the graph. So we say that it's symmetrical. Something that is symmetric, it means that the left side equals the right side when you cut it in half. That dashed line has a name, and the name is called, the name is axis of symmetry. But I want you guys also to look at something else. When I look at two different numbers on the table. I look at the 1 and the 2 right here, and I make a table around here. And I look at the same thing with the -1 and the -2 on the x-axis, or not the x-axis, sorry, the x values of the t-table. Notice what happens with the y values. We also have a 1 and a 4. So that pattern, we can use it to graph the parabola, the quadratic function. So I'm going to show you guys the pattern, and we are going to find different points to graph the parabola. Now, how many points do we need? Well, I like to use 1, 2, 3, 4, and 5. So I don't need to have more than 5 points. That's going to be more work. Does it help? It does, because it's going to make the graph more accurate. But we're not looking for a really accurate graph. We just want to sketch. We want to graph the parabola by hand. So we just need 5 points. So I'm going to use the numbers 1, 2 for a pattern that I'm going to show you guys to graph it. So before we start actually graphing the parabola, let me explain a couple more things, and I do have some steps to show you guys and some components that you need for the parabola. So here you guys have a table or an actual picture of the parabola, and some names that you guys also have to know. And the vocabulary is very important because I'm going to start talking about vertex, axis symmetry, minimum, maximum, the y-intercept, and then later on we're going to talk about the x-intercepts and so forth. So let's go ahead and first understand the parabola. I just graphed the parent function of the quadratic function, the parabola, f of x equals x squared. But you guys notice that this graph on the picture, the points is not on this point here, is not on the origin. The one I showed you guys on the previous slide, it was on the origin. So that point, when it's not at the origin, then it's not the parent function. It's something else. So this graph is something with an ax squared plus bx plus c. A, b, and c are going to be numbers. The points on that parabola, the lowest point is called the vertex. Now sometimes, guys, that U shape is going to go down. It's going to be like upside down U. So when it goes down, you're also going to have a vertex, but we're going to start looking at the minimum and the maximum. So look at here. The vertex is the lowest point or a minimum, and this is when the U shape is going up like this, or it's the highest point or maximum when the U shape is going down and upside down U. Something else you also have to know is how to find the dashed line that cuts the parabola in half, which is the axis of symmetry. So the axis of symmetry, first of all, you have to know it always goes through the vertex. No matter where the vertex is at, the axis of symmetry is going to go through that vertex. It's going to be a vertical dashed line. And I want you guys to do that on your paper. I would like to see the dashed line, axis of symmetry, every time you guys graph a parabola. How do we find the actual axis of symmetry? Well, there's an equation that we have to find it. And that equation of the axis of symmetry is x equals opposite of b divided by 2a. What's the a and the b? They come from the formula right here, ax squared plus bx plus c. So we're going to take the opposite of b on the top of the fraction divided by 2 times a, which is the one with the x squared. So once you guys plug in the numbers, you substitute, you simplify, and you got the x equals number. And that's going to be your axis of symmetry. Something else that we're also going to look for is the y-intercept. Now the y-intercept, you can't really see it here because this is blocking the y-intercept, but it's where the graph is crossing the y-axis. So right around here is where the parabola is crossing the y-axis. So that's going to be the y-intercept. The y-intercept is your c value in your standard form. So that constant, the number with no variable, is going to be your y-intercept. Something else that you also have to know is domain and range. So I'm going to talk really brief here what is the domain and range, but when we start actual graphing the parabolas, we are going to write the domain and range. So domain, remember domain, going back to chapter 2, chapter 3, chapter 4 from the book, domain are your x values, your inputs. So every time we look for the domain, we want to know what numbers actually work for the function when you substitute a number into the x. Domain is the x values. Domain in a parabola is all real numbers. So what that means is the x values can be any number in the number system. All real numbers, negative, positive, fractions, decimal numbers are going to work. Now the range are your y values, and that's going to be your outputs. Now what it means is for the range, when you substitute an x value, can you get a y value that works, that makes sense? Well, that's going to change every time we have a different parabola. And the range, the y values, will start at the vertex. And there's a little notation that you guys have to remember with inequalities. And I'll show you guys that when we do some examples. So you guys can start writing the range, okay? Some examples of how the equation looks like. I have some down here on the screen. This is the parent function, f of x equals x squared. So you guys can have just an x with the squared. That's one example of a parabola. You guys can have y equals 2x squared plus 3. So you guys look at the standard form. If you can be missing the bx term in the middle. So that's another example. You can have a f of x equals negative 3x squared plus 4x. There's no c value. The constant will be missing. Or you guys can have y equals x squared plus x plus 3, where you guys have the a, you have the b, and the c. So it depends how the actual equation looks like, but the shape will be a U shape, and it's going to have a vertex and an axis of symmetry. Now something else that also is going to help you guys is, and this is for more in the future, the shape of the U shape can be really, really wide open. So you guys can have a U shape really open. I'll give you guys an example here. So a U shape, you can have one going really, really open like this, or you guys can have a U shape really narrow, like this one here. This one is narrower, you can say skinnier than this one here. This one is really, really wide open. So that also can happen where the parabolas can be wide open or narrow. All right, so now that you guys know the shape of the parabola, you also have to know some components that we need for the graph. So look at those two parabolas that I have on the screen. The blue one is going up. You have a U shape going up. The red one is one that is going down. You have a U shape going down. You can say it's like kind of like a mountain. You guys are going up the mountain and then you guys going down. So that's a parabola that's going down. And then you guys have a U shape going up. How do you know which direction the parabola is going? Just by looking at the equation, the function, you can tell me the direction by looking at the value of a. And the value of a, if it's positive, then the parabola is going up. If the value of a is negative, then the parabola is going down. So that's just the number, the sign of the value of a. When the value of a is positive, my vertex is going to be the minimum point, which is the lowest point on that graph. So this point here is going to be your vertex. And let me just put a point so you guys can see it right here. So my vertex is a minimum. If a is, so this one, when the vertex is a minimum, a is positive. If a is negative, then the vertex will be a maximum point. It's going to be the highest point on that parabola. So the direction is down because a is negative, but the vertex is a maximum. You guys also need to know the x-intercepts. Now remember, x-intercept is just like the y-intercepts, where it crosses x-intercepts the x-axis. So this one here and this one here are x-intercepts, and this one here and this point here are also x-intercepts. But we have a few more names for those x-intercepts. We have roots, solutions, or zeros. So when someone is talking about those x-intercepts, they don't have to say x-intercepts every time. We can say roots, we can say solutions, or zeros. And something else that I don't have here, but I want you guys also to look at, is the y-intercept. So my y-intercept for the red parabola is right there. Let me just put y-int. And for the blue one, the blue parabola is right here, y-int. So keep in mind that to graph the parabola, you have a U-shape. The U-shape can be going up or it can be going down. And by looking at the A value, if it's positive, it goes up. If it's negative, it goes down. You guys will need to find the vertex of that parabola. And later on, we are going to find the x-intercepts, or you can say zeros, solutions, or roots. And something else that you also will need is the axis of symmetry. So I'm going to draw the axis of symmetry through the vertex so you guys know what to look for. So my axis of symmetry is going to be just a dashed line through the vertex. We are going to find an equation of the axis of symmetry. So let's just put here axis of symmetry. And it is axis of symmetry because it cuts the parabola in half and it makes it symmetrical. So that's why it's axis of symmetry. So on the blue graph, we have the axis of symmetry through the vertex again, and it is a vertical dashed line. So let me write down here, axis of symmetry. So I want to do one example with you guys where we want to identify the vertex of the graph and tell whether it's a min or max. And I also want to talk about the value of the minimum or maximum in that vertex. So I have two graphs, two parabolas, part A, graph A, and graph B. And let's look for that vertex. So remember that the vertex is the lowest point when it's going, the parabola is going up. So I am looking at the point right here. So let me just make a point, and that's going to be my vertex. I'm going to put V for vertex, and I need my actual coordinate of that point. And the coordinate is 1, 2. Now, which one is the vertex? Is it a min or a max? Well, when the parabola is going up, we say it's a minimum. And the minimum value of that vertex is going to be the y value of the point. So minimum, and we have y value 2. We say minimum value is 2. Something else that also helps you is once you know the parabola is going up, we can say the a value in that function is going to be positive. So we have a positive a. Part B, you guys have a parabola going down. So this one is going to have the highest point of that parabola. And the highest point of the parabola is right here. Let me make a point, and I'm going to find V again for vertex, but I'm going to find the coordinate of that point, which is 2, 1. Is it a min or max? Well, the parabola is going down, so when the parabola goes down, we say it's a maximum. And the maximum value of this point is the y value in that vertex. So maximum value is 1 because the y value is 1. How do we know what is the sign of A, positive or negative? Well, you look at the direction of the parabola. Since this is going down, the parabola is going down from here, then that means that we have a negative A. So in your function, in your actual equation, you guys have a negative number for A. Now in parabolas, you also have the axis of symmetry and the y-intercept. So let me just show you guys what that looks like. And the axis of symmetry is just a vertical dashed line that's going to cross the vertex of the parabola. So I know the parabola is 2, 1, and I'm just going to draw a dashed vertical line right here. And that's going to be my axis of symmetry. And my y-intercept is where it crosses the y-axis. So the parabola is crossing the y-axis right here, and I'm just going to label that as y-nt. The question didn't ask for those two things, but this is just something that is really helpful to know, because when you graph a parabola in standard form, you will use the y-intercept and the axis of symmetry. Now, if you pay attention to the y-intercept from this point to the axis of symmetry is 2 units away from that line. So the point to the axis of symmetry, 2 steps. If we look on the other side, well, if I count my steps, 1, 2, my other point is 2 units away from the axis of symmetry. So what I'm trying to say is the axis of symmetry cuts the parabola in half. So the left side equals the right side. The same distance from the points to the axis of symmetry on the left side is the same distance from the point to the axis of symmetry on the right side. Alright guys, I'm going to have to do a second video here to show you guys how to actually graph a parabola, and we're going to talk about in standard form. So check my video out, my second part, and if you like my videos, you can click on the like button. You can also subscribe to my channel. Make sure you guys practice, and I'll see you guys later.